Welcome back to the deep dive. So whether you're a coder already, maybe thinking about getting into software development, or you're managing a team, hiring folks, the tools we use, they fundamentally changed. We're talking AI, IDE assistants, GitHub Copilot, Amazon Q Developer, things like that. They're not just cool extras anymore. They're like right in the workflow. And our mission today, really zeroing in on you, the learner, is super important. There's just so much noise out there, right? Mixed evidence, conflicting reports. You see headlines about huge productivity gains, but then there are these serious warnings about security risks, even career disruption. So what we want to deliver is a clear strategy, like a playbook, for using these tools well, safely, and turning them into an actual advantage.
Yeah, and what's really interesting here is the data we have it's a bit of a paradox. You've got studies showing developers do get faster, especially on, the repetitive stuff. Generating boilerplate code saves mental energy, which is great. But then other research finds pretty limited gains, sometimes none at all, unless the AI is like deeply woven into the whole development process, not just used here and there. But the really critical point, I think, the thing we need to focus on is the challenge for new coders. Those tasks that junior devs traditionally cut their teeth on, boilerplate, simple configs, small bug fixes. That's exactly what AI is getting really good at automating. And that means the baseline skill level needed just to get in the door, it's rising fast. The focus has to shift, like right now, from just syntax to the core fundamentals.
Okay, that sets things up perfectly. So let's quickly make sure we're all on the same page. When we talk about an AI IDE assistant, it's way beyond just smart autocomplete these days, isn't it?
Oh, absolutely. We're talking about AI that's baked right into your editor, VS Code, IntelliJ, whatever you use, and it uses these powerful large language models, LLMs. So these tools can do some pretty complex things. Write entire functions, generate code just from you typing a sentence like, create a login form in React with basic auth handling. They can suggest tests, generate tests, explain confusing old code, even whip up Docker files or infrastructure configs.
Right. And we should probably mention the big names from the source material we looked at. GitHub Copilot, especially now with its chat feature, Amazon Q Developer that used to be Code Whisperer, remember? And things like Replit Ghostwriter too. A key difference often lies in how much context they can use, like just the current file or your whole project. Okay, let's tackle that evidence snapshot then, because this is where things can get, well, a bit muddy for people trying to figure this out. Productivity first, the headlines sound amazing. GitHub's own data suggests developers are faster, less cognitive load. Sounds like a clear win.
It sounds like it, yeah. But when you look at independent studies, the results are much more uneven if you're just using the AI in a vacuum, right? Ask it for a function without giving it the full picture, the project context, security rules, long-term goals. Well, the time you save writing might just get eaten up later in review and fixing bugs or security holes. To get those real sustained productivity boosts, you've got to integrate the AI across the whole development cycle. It's not just about banging out snippets faster.
That makes total sense. It's not about typing speed. It's about shipping solid, production-ready code quickly. And that leads us straight into the biggest risk factor we saw again and again in the sources, security and correctness.
Right. This is the crucial question, isn't it? What's the hidden cost of that speed? The consensus from the academic work is pretty sobering, honestly. Developers using these AI assistants, they often write less secure code compared to those coding manually. And there's this tendency towards overconfidence, assuming the code must be okay because it looks plausible, it runs, but it might have subtle flaws.
But hang on, why would that be? If it's trained on, like, billions of lines of code, shouldn't it be picking up the good patterns, the secure ones?
You'd think so, but that's the paradox. These models optimize for what's common and plausible in their training data. So, if a vulnerable pattern, let's say a classic SQL injection mistake, appears frequently in the code it learned from, well, the AI might just reproduce that pattern because it looks like typical code. Plus, it doesn't know your company's specific security standards, right? Or the approved libraries or the functions you've banned. It often defaults to generic and sometimes insecure code.
Wow. Okay. So trust but verify needs a lot more emphasis on the verified part. And speaking of risks, we can't skip the legal side. There are active lawsuits going on right through 2024, 2025. All that the data these models were trained on was copyrighted, and then who owns the code the AI generates? What are the licensing implications?
Exactly, and that legal uncertainty means companies and developers need to be really careful. If you're working somewhere that cares about intellectual property, every single line of AI-generated code could be a potential licensing headache if its origins are murky. You need a process to vet it, maybe even attribute it or rewrite it. The legal side is still shaking out, so caution and, frankly, intellectual honesty are key.
Okay, so if we pull these threads together, automation of simple tasks, the need for integration, the security risks, we absolutely have to talk about career disruption. This seems like the core issue for anyone starting out.
Yeah, historically, that junior developer role was often about learning through repetition, right? Setting up basic stuff, fixing small bugs, learning the ropes that way. But like we said, those are the very tasks AI is getting good at. And we are seeing early signs that this could shrink the number of those traditional entry-level positions.
So if the AI is handling the grunt work, does that mean new developers basically have to leapfrog that stage? How do you go from beginner to competent designer without that middle ground?
It's maybe less about skipping steps and more about shifting the focus right from day one. The demand isn't vanishing, but it's moving up the value chain. Companies need people with stronger skills in, like system design, real problem solving, the tricky stuff AI can't do, and deep domain knowledge. If you understand coding and the specifics of, say, logistics or finance or healthcare tech, that combination is becoming incredibly valuable, much more than just knowing syntax.
Right, okay, so this is the big takeaway for you, the learner, right? Synthesizing from all this,
Yeah.
just memorizing syntax, that's becoming a commodity. It's expected, it's table stakes. If you're learning now, what should be top of your list instead of grinding through API specifics for months?
The sources are pretty clear on the priorities. Number one, problem solving. Really breaking down big, fuzzy problems into smaller, logical, solvable pieces. That's key. Two, debugging and just understanding code. You have to be able to figure out why the AI's code isn't working or why it's insecure. That means deep comprehension. Three, design and architecture. Thinking about how systems fit together, how they'll scale, how they'll be maintained. That's long-term thinking AI can't do. And four, absolutely critical now, security and licensing awareness. This isn't just for specialists anymore. It's baseline knowledge for everyone.
That shift alone, prioritizing judgment and validation over just knowing the commands, that's huge. Okay, so let's get practical. The playbook. If you're learning today, what are the essential do's to build a future-proof skill set? First up, fundamentals. Got to strengthen those core computer science concepts. We mean data structures, algorithms, how operating systems work, networking basics, database principles. Sure, AI can spit out code for a hash map, but you need the judgment to know when a hash map is the right choice over, say, an array in a specific situation, considering performance and all that.
Absolutely. And tied to that, practice reading code, a lot of code.
Right.
See how experienced developers structure things, solve problems, because reviewing code is going to be a massive part of your job. AI might generate 100 lines fast, but your value is in reviewing those lines for correctness, efficiency, security, style. And that leads right into mastering debugging and testing, right? Those unit tests. Systematically hunt down bugs, validate every edge case the AI likely missed, and building on what we said earlier, really study secure coding. Like, know the OWASP top 10 vulnerabilities inside out. Understand things like buffer overflows, SQL injection defenses. You have to be the security gatekeeper. The AI won't be.
And here's a skill that's maybe newer but crucial. Prompting the AI effectively. Garbage in, garbage out, right. Clear, specific instructions are vital for getting decent results. It's not enough to say, write code to process data. You need to be specific. Write a Python function using only standard libraries to parse JSON with this specific structure, follow PP8 style, and handle network timeout errors gracefully. Precision matters. And finally, don't forget the process side. Version control, get, and code review workflows are non-negotiable. You need discipline around pull requests. Treat AI-generated code with at least the same skepticism you'd apply to code from a human colleague, maybe even more. It all needs careful review before merging.
Okay, now for the don'ts. These are the traps that can turn a helpful tool into a real problem, hindering learning or introducing major risks. Number one, the big one. Do not blindly copy and paste AI code, ever. Test it, review it, understand it, always. Number two, don't let the AI make you lazy about architecture or thinking long-term. It won't manage maintainability or plan future refactoring. That's still your job. And number three, super critical for security. Never, ever paste secrets, API keys, passwords, sensitive data into an AI prompt. These models can retain data. It's a huge security leak waiting to happen.
And maybe the underlying don't is philosophical. Don't think AI replaces learning. It can accelerate it, but only if you're actively engaged, questioning, validating. The moment you just accept its output without thinking, you stop being a developer and become, well, just someone relaying code, a human clipboard. All right, let's make this super actionable with some recipes based on where you might be in your learning journey. First phase, the learning phase, say, your first 0 to 3 months.
Yeah.
How do you use AI then without building bad habits?
The sources actually suggest something specific here. For the first, maybe 2 to 4 weeks, practice without any AI autocompletion. Seriously. Build that basic muscle memory for syntax, structure, how things fit together. Then, once you've got that foundation, start using AI mostly as like a superpowered tutor. So instead of asking it to write code for you, give it some code, maybe code you wrote, maybe example code, and ask it to explain it line by line. Use prompts like, explain this Python function step by step. What's its time complexity? List 3 edge cases where it might break. Now, see. It forces you to engage with the explanation, to really understand, not just get an answer.
That's a great technique. You're using the AI to deepen your understanding, not bypass it. I also really like the idea of using AI to generate tests for your code. Like you write a function, then prompt. Write 5 PyTest unit tests for this function, including tests for invalid input and null values.
Exactly. It immediately puts you in the mindset of thinking about edge cases and forces you to ensure your code is robust. You're using the AI to challenge yourself.
Okay, what about later on the projects phase? Maybe months 3 to 9, when you start building bigger things, connecting components. Here, the AI can be fantastic for the scaffolding, generating config files like Docker files, Kubernetes manifests, CI/CD pipelines, getting boilerplate HTML, CSS structures set up. This stuff can take hours, and it's often repetitive. Let the AI handle that. It frees up your mental energy to focus on the core logic, the system design, the really valuable parts.
Yeah, and here's a really active learning recipe for this stage. Write a piece of core logic yourself. Then ask the AI to generate a comprehensive set of unit tests for it. Now here's the key. Your next task is to deliberately break your function so it fails one of those AI-generated tests. Then you manually debug and fix your code until the test passes again. This constantly reinforces that crucial loop. Code, test, debug, understand. You're practicing the skills that matter.
Love that. It forces you to stay in the driver's seat, using the AI as a tool, but keeping the core skills debugging, validation sharp. So let's wrap this up. What's the final career strategy look like for someone in that critical 0 to 2 year phase? How do you stand out when everyone has access to these AI assistants?
The focus has to be on building, say, 3 to 5 complete projects, not just code snippets, but fully realized applications or systems. And these projects need to showcase the things AI can't easily replicate. That means demonstrating solid testing practices, clear documentation, thoughtful system design choices, even basic ones, and critically, showing you understand security implications and maybe some cloud fundamentals.
And when you present these projects, maybe in a portfolio or interview, you need to talk about your process, right? Not just, I built this, but here's how I used AI for initial scaffolding, but then here's how I rigorously tested its output, checked for vulnerabilities like X and Y, and ensured the architecture was maintainable. Embrace the speed, use it to learn faster, prototype quicker, but never ever outsource your judgment. That seems to be the core message.
Absolutely. And there's one more thing the source material highlighted that's really thought-provoking. It's about education itself. Educators are realizing they need to shift away from exams that just test syntax recall. They're moving towards open book assessments focused on problem solving, and they're adding AI literacy, knowing how to prompt, validate, understand the risk directly into the curriculum. So, the provocative question for you, the listener, is this. If the entire system education hiring is shifting to prioritize validation, critical thinking, and ethical judgment over rote memorization, how do you need to change your personal learning strategy starting today to build that capability? If the world now demands proof of your discernment, what specific steps are you taking right now to build that crucial muscle?